Hi there everyone. Welcome to the video lecture series on double integration. Let us continue our discussion in detecting the type of region and writing its corresponding double integral. In front of you I give you this question, okay, where the shaded region is bounded by y square equals to 2x, which is a parabola, x square plus y square minus 2x equals to 0, which is a circle, and y equals to x, which is a straight line. Okay, now you can see the shaded region over here. Whenever the region is given along with its equations, what we do is we first go to find the intersection points, if any. We can see here that the two intersection points are there. We need to find them. So let us first find the intersection point when parabola and straight line intersect. When parabola and straight line intersect, put y equals to x in the equation of parabola. You get a quadratic x square minus 2x equals to 0. On simplification, you get x equals to 0 and x equals to 2. When x is equals to 0, you plug this value in the equation of the straight line. You get the point y equals to 0, and the point will be origin 0, 0. Okay, when x equals to 2, you again get y equal to 2, and the point will be 8, 2, 2. Write these values on the diagram for the simplicity, and now we go for finding the intersection point x square plus y square minus 2x equals to 0, and for the straight line when they intersect. So again, on similar lines, you put y equals to x. You get a quadratic x square minus x equals to 0. Again, you get 2 points, x equals to 0 and x equals to 1. For x equals to 0, you will get again the origin o 0, 0. But when x is equals to 1, you get y equals to 1, and so you get a new point b 1, 1. Put it up on the diagram. Okay. Now comes the most difficult and the crucial part of understanding the diagram as a type 1 or type 2 region. So let us see how to detect when we don't have any clue whether the region is type 1 or type 2. What comes here, the most important thing is that we are expected to do some rough work. Okay, so this rough work you can do either at the back of your mind, just by visually thinking properly about the diagram, or what you can do is you can draw small diagram at the corner of your answer page or your rough page and try to check the following thing. Just draw the vertical straight line passing across the region. Okay, I have drawn here this purple line. What I can see, it first enters at the circle and exits at the parabola. Again, when I draw this line over here, I see it enters at the straight line and exits at the parabola. Okay, now what I recall over here from the theory, that if the entry and or the exit points are different, then the double integral is going to split. What we can see, the entry point are different over here, so the double integral in the case of type 1 is going to split. Okay, let us check what happens if we try to see this region as type 2 region. Okay, so when I try to see this region as type 2 region, over here when I draw a horizontal line, I see the entry point is the parabola and the exit point is the circle. But what happens over here, again, entry point is the parabola and the exit point is the straight line. Okay, now in either of the case, if we try to see this as type 1 or type 2, we see that our double integral answer, the writing of the double integral, is going to split. Okay, so what conclusion we derive from this understanding of this diagram, that this region is neither of type 1 nor of type 2, because in either of the cases the entry point or the exit points are different, right? They are changing each time. So let us see here. I'll erase this and we'll see in a better way. So for the first time we will try to see this as type 1 region, and we will see how our double integral is going to split. So when I draw the straight line over here, the vertical line passing across the region, the entry point is the circle and the exit point is the parabola. Okay, now again we pass this line. We see here the entry point is the green dot and the exit point is the blue dot. Okay, what happens now? So we see that it is splitting up. Okay, so it splits up at the point B. Let me draw a vertical line over here. I'll call each of the region as S1 and S2. Now for the first region, the projection is going to be O to 1. Okay, so yeah, it's going to be here O to 1 over here. So and here you can see, so when you write S1 and S2, your double integral will be written in this manner. Double integral over region S1 dy dx is the order of differential that we are expected to keep, and other plus double integral S2 f of x comma y dy dx. Okay, and the projection of this region is going to be, for S1 it's going to be from 0 to 1. Okay, now when we are writing the double integral for S1, we need to understand the entry point in terms of equation of y equals to something, right? So the equation of the circle is given to us as x square plus y square minus 2x equals to 0. Okay, so we will write this as y square equals to 2x minus x square, and then y becomes plus minus square root of 2x minus x square, and this y is equals to, because it is the upper semicircle above the x-axis, alright, so we will have the positive square root over here, 2x minus x square. Okay, so that is the lower limit of S1, the innermost integral, for the innermost integral here. And for the parabola, you will have y square equals to, here you have y square equals to 2x, and so the positive square root of parabola will give you square root of 2x, right? So what you have here, the first integral is this way, and the projection being the from 0 to 1, so the limits of x are x equals to 0 to x equals to 1. Now for the second double in here S2 over the region S2, what you will have is the projection falls from here, it is from 1 up to 2, right? So for S2 the projection is from 1 up to 2, and the lower limit over here is for the straight line y equals to x, and here again it will be y equals to square root of 2x as the upper limit. So the double integral will be written as y equals to x up to y equals to square root of 2x, and the projection limits are up to from 1 up to 2. So this is how you see this region, and this is when we try to see this region as type 1 region. Okay, now let us see this region as type 2 region, and one of the most important fundamental concept is going to come there. So let us see the same region we are taking further. Okay, what happens when we try to see this as type 2 region? Okay, so firstly here we will need to draw at the point B, we have, since we are trying to see this now as type 2, and we know that it is neither a type 1 nor a type 2, so the region splits over here. At B we draw a horizontal line, okay, and this horizontal line cuts y-axis at 1. Okay, now let us see the region. Instead, now previously they were S1 and S2, I am now naming them D1 and D2. So our double integral will be d1 d2, and now see the order of differential, it is dx dy. Okay, let us see how to tackle them further. When I pass a horizontal line across d1, what I see, its entry point is at the blue dot and the exit point is at the red dot. It is the equation of the circle. Okay, so when I write for the lower limit over here for x, when I write it's the parabola, I have y equals to 2x, so it will become x equals to y square by 2. So that's not an big issue, so we can write down. But what happens with the upper limit? Here comes the most crucial part. Let us see. We have the equation of the circle, that is y square plus x square minus 2x equals to 0. Now what we need is, when we simplify this, because we need x equals to, right, we need the entire equation in terms of x, so we will need to do the completion of the square. So completion of the square lands up us on x minus 1 the whole square plus y square equals to 1. Okay, and further when you simplify this, you will get x minus 1 equals to plus minus square root of 1 minus y square. Now comes the difficult part. Which equation we should choose? Should we choose the positive part or should we choose the negative part? Some of you will say that we should go for the positive part, and some of us will be in a confusion. Let me remove this confusion here. See here, let me write down this here. I'll show this part with the help of some explanation. Recall the lecture in which that we had seen equations of semicircle and the circle. One of the part for semicircle here, if this, I'm just roughly drawing this diagram of semicircle here. If I write this equation as a for the semicircle, we remember that for this we had written down the equation as y equal to, we had written this as square root of a square minus x square, right, because y was positive. Okay, and we had also seen another equation here for this semicircle, when this is minus a, and for this we had written down that x equal to minus of square root of a square minus y square, right? So when this two semicircles, if you consider, they are both formed from the main equation x square plus y square equals to a square. Recall over here that you can see this part is common to both. I am shading here this region, this boundary here. You can see this semicircular quarter is common, right, is common to the both the equations. How do we then deal for this quarter? Because here basically this is the circle which is shifted from the center, or if you call it from the origin, it is shifted. So how do we detect this part as which part equation should we use? Okay, so from the discussion here, if you see that this is for y and we need equation in terms of x. For x, when we are trying to write, we are bound to choose this as our answer, that is minus of square root of a square minus y square. Just because the diagram is in the first quadrant, okay, do not be in a hurry to just take the positive square root. Here it is very crucial that this is very important part, which equation should we choose, because you can see here y equal to, if I write y equal to square root of a square minus x square, it's not going to work. We need the equation in terms of x. Now the another option comes here, so this option goes wrong. We are not interested in that, but you can see there is an overlap. Both equations take care of this quadrant, right? This second quadrant, the curve of a semicircle lying over there, it is taken care by both the equations. But which one we need? We need the x equals to minus or square root of a square minus y square version. So over here, observe that because this circle is shifted, we will have little change in the equation. The change here is x minus 1 equals to minus square root of 1 minus y square, and further our equation will now appear like this, that it is x equals to 1 minus square root of 1 minus y square. This is what is important. Okay, you can see this is the standard circle with radius a we had taken in our discussion. Now what we have over here, the circle is shifted. Okay, it is shifted by 1 unit. So what we do, we will need that because the center is shifted for this circle, the center is 1 comma 0. Okay, so that change is incorporated over here, and we need to understand here that the circle that you see, which is in the first quadrant, the semicircular region, okay, the arc OB, which is in the boundary, it is the part of this equation, okay, and not of positive part. If you take here x equals to 1 plus square root of 1 minus y square, it will become wrong. This is absolutely wrong. You will need to choose here x equals to 1 minus square root of 1 minus y square. That's the whole important part here. So the upper limit will become x equals to 1 minus square root of 1 minus y square. Now what about the projection? Projection is going to fall on y axis, so it's going to be from x equals to from y equals to 0 to y equals to 1. So those are the projection limits. Alright, what about the other part? For D2, we will have, when you draw the line, the entry point is at the blue dot and the exit point is at the green dot. Okay, so the entry point is the parabola. So again, it's not a difficult part. Okay, so it's going to be x equals to y square upon 2, and the exit point is the straight line, so x equals to y, and the projection limits are going to be from 1 up to 2. So that was easy, but the most important part over here in the discussion is regarding this. Okay, so please be very careful while writing down the double integral and writing the form of the equation that we need. Okay, so this was all about the types of the region that we have seen, and the how to write its corresponding double integral. So till then, I shall meet you in other video lecture. So take care and keep solving good amount of mathematics. Please hit like and subscribe to my channel so that you can see more videos upon the following topic. Till then, thank you.